and welcome to another video in CHE 101. So today we'll be discussing a topic in Cal Eng 2 or Integral Calculus, and this will be about U-Substitution. This discussion will be divided into two parts where we'll be solving 12 problems, which we will see later on. So I'm Monito Felias. You may contact me through my email, monito_felias@dlsu.edu.ph. For the outline of our discussion, so first we'll be introducing U-Substitution, and then we'll have the formula sheet to be used for all of the problems that we will be solving. Then the sample problems, where we'll have the list of questions and the complete solutions, and finally the list of answers. Throughout the video, please try to solve the problems first if you can, and then just use this video to check your answers because that's the best practice, I believe, in studying calculus and a lot of other subjects in chemical engineering. All right, so to begin, U-Substitution. This is the counterpart of chain rule in differential calculus. So we've probably learned about this in Cal Eng 1. The chain rule is a way of solving, of finding the derivatives of functions which are composites or functions inside the function. And U-Substitution is the counterpart of that. Again, it's a method of solving composite functions. And here are the general steps in solving U-Substitution. So first, we have to let U be a portion of the integrand f of x. And then we will be solving du in terms of x and dx. So it's like taking the derivative of u. So du with respect to x, or d over dx of u. We will be solving du then in terms of x and dx. And then step 3 is to substitute u and du into the integrand. Step 4 is to solve for the value of the integral in terms of u. So after substitution, the given should be simplified, where we'll have u and du instead of x and dx. And then we can easily solve for the integral in step 4. And then finally, we should be undoing the substitution so that our final answers is in terms of x. We'll see how these steps can be followed in the next examples. Okay, so for the formula sheet, first you may take a picture of this slide. We'll be using these formulas throughout the video. So all of the formula that we'll be needing are in this slide. All right, so for the next part, this is the list of questions. We have 12 questions, and for this video, we'll be answering the first 6 questions. Okay, to begin, first question, we are asked to find the integral of x over x plus 1 dx. Again, the first step is to let u be a portion of the integrand f of x. And in here, the trick in finding which part should be u is whatever complicates the function. So which part makes this integral difficult? And first, we can try the denominator, because once the denominator is simplified, then maybe the entire function can be simplified. So let u equals x plus 1, and then du would be dx, because the derivative of u with respect to x, d over dx of u, that's d over dx of x plus 1. And that's just equal to 1. So d over dx of x plus 1 is equal to 1, which means du is equal to dx. I hope you followed that. And then just another addition, x would be equal to u minus 1 based on our substitution. And then substituting all of these values into the original given, x, we know this as u minus 1, and then x plus 1, we know this as u. So that would be u minus 1 over u. And then dx, we can replace that with du. So we now have a new function, u minus 1 over u du. We'll take the integral of that. And we can separate this into two terms. So we'll be having the integral of u over u minus 1 over u du. And then we can just apply the basic integral rules. Further simplifying this, we'll have integral of 1 minus 1 over u du. And then the integral of 1 is just u. The integral of 1 minus u is the natural logarithm of absolute value of u. And then, of course, we'll have to add the constant of integration c. So as we can see, we follow the main steps. Let u be a portion of the integrand, and then solve du in terms of x and dx. And then we substituted, and then we solve the integral here in step 4. And then finally, we'll have to undo the substitution. So u, that's x plus 1. And then u again, that's x plus 1. So our final answer would be x plus 1 minus ln x plus 1 plus c. But remember that c accounts for all of the constants in the final answer. So we can just merge this constant with this. It could be absorbed by the constant of integration. This is then our very final answer, x minus ln x plus 1 plus c. Okay, moving on to our next problem. This is number 2. We are asked to take the integral of 2 raised to x over square root of 2 raised to x plus 4 dx. And we might be tempted to use the entire denominator as u because it's very complicated to look at, but we'll have to consider that we'll be solving for du as well. So du should also be another way to simplify our given. So what if we try whatever is just inside of the square root? So let u be equal to 2 raised to x plus 4. And if that is our u, then our du would be equal to 2 raised to x natural log of 2 dx. And this is one of the formulas that we have in the formula sheet, taking the derivative of constant raised to x. And then solving, simplifying this, du over ln 2 would be equal to 2 raised to x dx. And then step 3, we substitute u and du into the integrand. We know that 2 raised to x plus 4 is u. So we have square root of u here. And then 2 raised to x dx is equal to du over ln 2. So 2 raised to x dx is equal to du over ln 2. And then once those are substituted, ln 2 is just a constant, so we can factor that out later. We can now solve for the integral. So factoring out 1 over ln 2 times the integral of u raised to negative 1/2, that's the 1 over square root of u du. And then solving this is just equal to, this integral is equal to u raised to 1/2 over 1/2. And then further simplifying this, we'll have this final answer for u after substituting u. And then undoing the substitution, we have this answer, 2 raised to 2 times the square root of 2 raised to x plus 4 over ln 2 plus c. Okay, I hope that's clear. Next problem, this is problem number 3. The given is the integral of 3 raised to 2x dx. And it doesn't look very complicated, but maybe we can simplify this because we don't have really a formula where the exponent is another function. So let's try replacing that exponent with u. So let u equals 2x. Du would then be equal to 2 dx. And du over 2 is equal to dx because we only have dx here. We'll be needing du over 2 in replacing that. And then substituting u and du into the function. So we'll have 3 raised to u times du over 2. And remember that the integral of 3 raised to u du is equal to the 3 raised to u divided by ln 3 plus c. So this is just like the reverse of the of what we did earlier in problem 2, where we took the derivative of a constant raised to a function. And then applying that rule to our given, the integral 3 raised to u times du over 2 is then equal to 3 raised to u over 2 ln 3 and then plus c, of course. And then undoing the substitution, u is equal to 2 raised to x. We'll just be plugging that in back. The final answer is 3 raised to 2x over 2 ln 3 plus c. Okay, moving on to number 4. We are going to be integrating dx over the quantity x plus 4 squared. And then here, again, the part in the denominator that is inside the bracket, inside the parentheses, is the part which probably complicates the problem. So maybe we could try letting u be equal to x plus 4. And then du would then be equal to dx. And then substituting u and du into the problem, we'll have du over u squared. We take the integral of that. That's simply applying the power rule in integrals. So the integral of u raised to minus 2 du is equal to u raised to minus 1 over minus 1 plus c. And then we can rewrite that as negative 1 over u plus c. Then doing the substitution, our final answer is negative 1 over x plus 4 plus c. Okay, so that's kind of quick. For next problem, number 5. So we will be integrating secant of 2 theta times tangent of 2 theta d theta. And this part, whatever is inside of secant and tangent, we can probably substitute u in there. So let's just try that. Let u be equal to 2 theta. Du would then be equal to 2 d theta. And du over 2 is equal to d theta. Substituting u and du into the function, we'll be having the integral of secant u times tangent u times du over 2. So secant u times tangent u, and then d theta is du over 2. And then in here, let's remember that the integral of secant x tangent x dx is equal to secant x plus c. This is another formula from our formula sheet. And it looks a bit direct from based from our given. So the solution to this integral is secant u over 2 plus c. Then doing the substitution, we'll have secant of 2 theta over 2 plus c. This is our final answer. And our last problem for part 1, this is the integral of x times e raised to negative x squared dx. And the part that probably makes this question harder is the exponent of e. So let's try letting that be equal to u. So let u equals negative x squared. Du would then be equal to, the derivative of this is negative 2x. Du is equal to negative 2x dx. And solving for x dx, that's equal to negative du over 2. The reason we solve for x dx is because we can see this in the given, x dx. So we can substitute this part later on. And then substituting u in du, x dx is equal to negative du over u, and then u is equal to negative x squared. So we have the integral of e raised to u times negative du over u over 2. And that's just simply negative e raised to u over 2 plus c, because the integral of e raised to u is just e raised to u. And then we have the negative 1/2 factor, and then plus c. Again, undoing the substitution, our final answer would be negative e raised to negative x minus 2 over 2 plus c. So that ends the part 1 of U-Substitution video. These are the answers once again to the first 6 problems. And again, the list of questions, all 12 of them. So we've answered the first 6. On the second video, we'll be answering 7 to 12. This set is a bit more complicated compared to the first part. So if you want to try them first before checking your answers, please do so. And just use the video or some other means to check your answers. If you have any questions, you may contact us in through our email or our Facebook page in these links. And that will be all for the first part of U-Substitution. Thank you very much for listening and watching Che 101.